This is unit 5.2. From this point forward, you can see that the mathematical equations and the way we solve the problems, the analysis, are a lot more complex. So hang in there, guys. Practice makes it perfect. We'll take it one step at a time. Okay? Some concept first. Equations as functions. In the previous unit, we talked about functions are a special kind of relations where for each x input value, we have only one output value, and we use the vertical line test to evaluate that. Now, in this unit, we're going to learn function can also represented by an equation. And the equation will generate ordered pairs by taking an input, which is my x, it's also called domain, and spit out a one output, which is a y. The x value is always called independent, meaning I can grab any value independent from anything and everything. But the outcome, the y, will be a dependent variable because the outcome y depends on a certain rule that connects x and y. The graph of equation is the set of all its ordered pairs, which often form a line or a curve. In this course, we mostly study the line. I'm going to move the sheet upwards. So keep that in mind. Input, output, domain, and range, x and y. Now let's look at if we have ordered pairs, we have function, we have ordered pairs, we have table, and we have graphs. These three things always go together. So now here is a function, y equals x plus 7, and the input is right here, all the independent variables. And the rule, like we said, is x plus 7. That's my equation. So wherever I have x, I just have to replace with all the values here. I'm just highlighting in green. And then I would arrive at y. And if I want to highlight y, I will use the color red here. Okay? So let's see. So when x equals -1, you plug it in. You arrive at 6. -1 plus 7 is 6. So if I write it into my ordered pair format, it's -1, 6. Then next, when x equals 0, 0 plus 7 is 7. So now I have 0 and 7. 2 plus 7 is 9. So I have 2, 9. And finally, 4 plus 7, wherever I have x, I replace it with the green 4. I land in the red 11. So it's 4, 11. If I want to be color matching it, the green should match up and the red should match up. Okay? Same thing with y equals x minus 13. Whoops, let me change the color to blue. X minus 13. So 3 minus 13, your calculator should give you -10. So you should have 3, -10. 6 minus 13, you should have -7. And your calculator should give you this. 9 minus 13, you should have -4. So it's 9 minus 4. 12 minus 13 gives you -1. So it's 12, -1. That's how we calculate the ordered pairs. Okay, so again, the methodology is that you take the equation, and the equation is on top here, and then you put it over here. The equation is the rule. Remember that definition? And wherever you have x, you just replace that x with what I highlighted in green. And then you throw that into the equation, you should come out with a y value, and therefore you have your X and your Y, you put it into the ordered pair format. That's all. So at this point, I want you to press pause, finish 3, 4, 5, 6. When you finish everything, you come back and hit hit play again, and so that you can verify your answers. Okay? And I will write the answers down on the sheet below here. Okay, I have put the answers of 3 and 4 on the screen. I'm gonna move it up a little. And I will do the 5 and 6 because there are fractions involved. So again, plug in 1/2 times -6 minus 9. You use your calculator, you should have -12. 1/2 times -2 minus 9, you should have -10. And then 1/2 times 0 minus 9. Those are one of my favorite numbers because anything times 0, give me 0. 1/2 times 14 should give me 7. 7 minus 9 should give me -2. So that is your number 5. And then you just gather all the x's and match it with all the y's. You just rewrote your order pair in here. So this x is 14 and -2. Okay, same thing here in number 6. -9 times -4/3x plus 11, you should have 23. -3 times -4/3x plus 11, that should be 15. 3 times -4/3x plus 11, you should have 7. -4/3 times 6 plus 11. Oh, I'm sorry. I made a mistake. I'm sorry. I plugged in the x, but then I also, I shouldn't, because the x has been plugged in already, I shouldn't have the x there. So another mistake made by Miss Burge. Let's see. Now I'm the one doing push-ups in class, right? So that should give me 3. So now you gather all the x's. Oops, that's positive 23, -3, positive 15, positive 3 and 7, and I have 6 and 3. So that's how we use the equations. And when one value, in this case mostly it's all x values are given, you throw it into the equation to calculate the y. So you find that dot in the coordinate plane and you express it in ordered pairs. Okay? This is the second video for Unit 5.2. And we'll continue the discussion about using tables to analyze functions. So here we have given each function and domain, find the range values. So we have function, that's given. We have domain. Remember, domain is all x values. And then we're asked to find the range, which is the y value. And so we take each function. In the first example, we have y equals x minus 5. And we have 3 values in the domain, 4, 6, 8. Therefore, you have to plug in 4 first. And now y equals -1. Second, you have to plug in 6. And then you should have y equals 3. I shouldn't have written that. I apologize. Let me erase this. It's easier if I illustrate it like this rather than to continue to go on. What did we say? This is 1, right? And when x equals 8, I have y equals 3. So my range, my final answer is this little bracket. I have all the y values. Notice where are the y values here? I have I have -1. This is -1, -1, 1, and 3. That's my range. Okay, then you do the same thing with number 8. Wherever you have x, you plug in the first given x, then you calculate it, and then you end up having y equals -2. Then you continue with y equals 0, so 3 times 0. Anything times 0 is 0, plus 1, and y would equal 1. And the third one is 3 times 1 plus 1, and y equals 4. So now your range is -2, 1, and 4. Close bracket. Okay? For number 9 and 10, again, I want you to press pause now and complete it. And when you're doing that, I will finish writing, posting the answers, and you can come back and check your answers. Okay, I wrote out the answers for 9 and 10. So please verify them. If you got one wrong, make sure you correct them. At this point, it's smarter if you can keep some scratch paper in an orderly manner and attach it to the bracket. That's just a study skill that's nice to have. Okay? Moving right along, we're going to go into something that's really important in Algebra 1. Very basic skills, but it's used every single day by mathematicians and math students everywhere in the world, which is graphing. And especially graphing based on certain characteristics of the functions. So let's look at it here. The first half is not foreign anymore. We have an equation, and then we have, right, we have given equation, we have given x values, and we're asked to solve the y value and then write it into ordered pairs format. So this part should be very familiar. Y equals x plus 3. So wherever there's x, I substitute it in. I should have -4. My answer is -7, -4. Okay, so here again, pause it, finish it, and then come back and verify your answers. Please take the time to finish this, because if you just copy it down, it doesn't help you anything. You're making yourself a Xerox machine, and I can guarantee you this problem will show up in tests and quizzes. So press pause. Okay, these are the answers to the 2 equations that you have. I do want to go back and demonstrate this equation. This equation is y equals x squared. So the calculation, the rule here should be x squared. I'm going to actually rewrite this, just put x squared in here so that you know that's the operation here. So whenever there's x, -3 squared, that means -3 times -3. That's how I end up with 9. And just make sure that -3 squared is different from -3 times 2. Squared means you multiply the base twice by itself, okay? So now how can we graph it? Let's go back to look at equation 1. I have all of these coordinated, I have all of these ordered pair here. So I take the ordered pairs, find the dots first. -7 and 4. So I have 1, 2, 3, 4, 5, 6, 7, and 1, 2. -7, -4 is here. Okay, I'm going to make that cleaner. And then -3, 0 is right here. 0, 3 is right here. 2, 5 is right here. 5, 8 is right here. Now, really within 2 or 3 points, more like 3 and 4 points, the first 3 and 4 points, you have already discovered the pattern here, if you've noticed it, that if you just connect the dots, it gives you a straight line. Okay, all the points should be rested on that line. All the points, if I just make this a little bit more accurate, if I graphed it a little bit more accurate, and when I drew it, if this pen can be a little bit more precise, I would be I would be able to cover all the points, but you got the point there. Now, let's look at the second thing. Second equation, I have -3, 9. So -3 is here, 9 is on top here, right? I have -2, 4. -2, 1, 2, 3, 4 is here. I have 0, 0. I have +2 and 4. I have +3 and 9. So if I were to connect this, I have to go something like this. And then it keeps going for both equations. These are just a few examples. It's just a few examples that's listed in the table, but clearly you can tell if I just keep going at this, I would end up having an endless curve that will pass through these critical points demonstrated by what's on the table, right? -3, 9, if I use a different color. -2, 4 is right here. +4 is here. I'm a little off there. And 0, 0 is here. I'm a little bit off on the right-hand side. I apologize. It's a little too fat on the right-hand side. So then you just erase it. That's why it's important at this point to have here we go. Oops. That's why it's important to use pencils, because then you can erase your own mistakes easily. That's where I should head it to. Then my red curve goes up like that. That would get these points covered. +3, 9, and 2, 4. Okay. Now let me move the sheet up a little so that we can see. Then it wouldn't move my thing. Okay, that's okay. I can work with this. So notice here at the bottom it says the first equation, obviously, what shape is it? It's a line. It produced a straight line. So it's called a linear. Linear means it comes from line, right? It looks like a line. A linear equation. And the second equation produced a curve. So it's called a quadratic equation. And Algebra 1 studies primarily these two. And in this unit, we will focus, and there should be a thing there, we should focus on the study of linear equations. All right, so that's the second video of this unit. For the rest of it is all practices of the same. So give it a try, and I can guarantee you that all of these will show up in the quiz. I will produce more practices, but let's get going, guys. Thank you. Bye-bye.